Hello everybody. Today in class we went over this worksheet. Last night you should have watched a video on ionic compounds number 1. So now this is the video for ionic compounds number 2. Everything we do today is the same as what we did last night, what we did today in class. But there's one little addition that is really what can make this complicated. And I don't even want to say complicated, it just adds a little bit of fun, let's say sarcastically, to what we're doing. It's what students in the past have found the most difficult. So we've already done this. We have done positive and negative, positive metals, negative nonmetals. Well, we have one little thing to add to this. If you look at tonight's homework, you will notice that for the most part, almost everything over here on the left is still a metal. There's one little weird thing here. But everything on the top is no longer just a nonmetal. You will not find nitrate and sulfate and carbonate on the periodic table. So that's what adds our little interesting aspect to this. So what I want to show you today is the fact that almost everything that we did yesterday, or today in class, as I should say, last night's notes, today's homework, almost everything we did, or everything we did yesterday, looked like this. If we had Mg plus 2 and O minus 2, both of these are what are called monoatomic ions. But as I just showed you on the homework that you're going to do in class, you see things that are not monoatomic, because mono means one, atomic means atom. So to say something is a monoatomic ion, it's an ion, it's a particle with a charge, but it only has one atom in it. This is magnesium. This is oxygen. But you'll see on the homework, you have several things that are like this. This has obviously more than one atom in it. It's got at least 3 oxygens because there's a 3 behind it. Actually, this has 4 atoms in it. There are 4 atoms in this ion. 4 because there's 1 carbon, but we never ever write the number 1, so that 1 disappears. 1 carbon, 3 oxygens. This has 4 atoms in it. But those 4 atoms, when they come together, end up with a negative 2 charge. This is what is called a polyatomic ion. Poly means many, or in other words, more than one. And more than one is 2. So there will be a polyatomic ion you have on the homework that has 2 atoms in it. It's still a polyatomic because it has more than one. Polyatomic ions make us do something just a little different, but we will add something to our flow chart that will show us when and why we do that. So let's just show a couple examples and show why this is a big deal. If I gave you magnesium plus 2 and oxygen minus 2, if you go through your flow chart, are the numbers and the charges the same? The answer is yes. You take the charges off and simply squeeze everything together. MgO. That's an answer that was on the first worksheet. Well, if we do that and keep the positive ion, but now instead of a monoatomic ion, we do a polyatomic ion, 4 atoms, but 1 single ion. It acts as a single unit. We still go through the flow chart. Are the numbers in the charges the same? The answer is yes. So you simply drop the charges. This is the positive ion. Drop the charge. But now instead of only writing an O, we have to count this whole thing as the negative ion. So this would be CO3. MgCO3. No big deal. Might be polyatomic, but we just did it the same way and nothing changed. But now let's try, instead of magnesium, let's do aluminum. Aluminum with a +3 charge, oxygen with a -2 charge. If we go through our flow chart, are the numbers in the charges the same? No. Can they be reduced? No. Drop and flip. Aluminum, what number do we put behind it? 2. Then the negative ion, oxygen, and what number do we put behind it? 3. Nothing weird. That was on the homework that we did today in class from last night's homework, or last night's notes. But here is where it becomes a little bit more of a challenge. We're going to do aluminum with a +3, but let's use carbonate like we did in the previous problem. We are now going to say aluminum with a +3, CO3 with a -2. Let's do this like we've done every problem we've ever done. Al with a +3, CO3 -2. Are the numbers in the charges the same? No. Can they be reduced? No. So now Al, what number do we put behind it? 2. Here's where we got to be careful. This is the entire negative ion, CO3. That whole thing, just take the whole thing, make it the negative ion. But now we got to put that number behind it. If we put that number behind it, what does that look like? That does not look like 3 carbonates. That looks like Al2CO33. I don't want 33 oxygens. I want 3 carbonates. How do I show that? You put parentheses around the CO3. So, for that reason, I want you to add something to your flow chart. On your flow chart, I want you, if I can find it, on your flow chart, I want you to add something to the very bottom. This, you will only use parentheses if you make it to the third question. So at the bottom, if you have more than one polyatomic ion, you must put parentheses around it. Please do not get in the habit of simply just putting parentheses around everything. I don't know when to put parentheses around stuff, so I'll just put them around everything. Don't get in the habit of that. Don't do that. Use this flow chart, and I'll add this little thing that you should have in here as well. If you have what I have in red here in your notes on your flow chart, just realize that when you get to the bottom and you start to drop and flip, when you start to drop and flip and you start to notice that, oh, that's a polyatomic, and oh, I'm going to have more than one of them, then you have to put parentheses around it. It becomes clear a lot of times when you try to do this, and if you don't put parentheses, you end up with a number like 42 when you meant to say SO4 and you need 2 of them. So please put parentheses around them if you have more than one polyatomic ion. Let me quickly find one where I know you need parentheses on tonight or on the homework, and I'll show you one that is one that needs parentheses. One that for sure is going to need parentheses is this one right here. Let's use the flow chart and figure out what this answer would be. So we are doing Ca plus 2 and phosphate, PO4 minus 3. Do they have the same number in their charge, 2 and 3? No. Can they be reduced? No. So now we're down to drop and flip, and that's a polyatomic. So your polyatomic radar should be on high alert because you might need parentheses. So our positive ion is Ca. How many of them do we need? 3. Our negative ion is phosphate, PO4. But how many PO4s do we need? We need 2 of them. If I don't put parentheses here, that looks like 42, and that is not my intention. I have to put parentheses around that PO4 and then say 2. Ca3 parenthesis PO4 parenthesis 2. That is the answer, and the parentheses are required because we have more than one polyatomic ion.